Good afternoon, everyone, or good morning, depending on where you're attending this webinar from. First and foremost, I would like to thank you all for taking time out from your schedules to attend this webinar. Welcome again. Today's topic, remote management and data access of solar PV systems. This webinar aims to provide a high-level insights on data acquisition mechanisms commonly adopted for centralized solar PV systems. We will have a look at how kalikiio as a cloud software solution helps in acquiring data from various assets and devices deployed in the field and helps in diagnosing issues using vendor-specific tools remotely. Commercial and industrial power producers can utilize the platform to collect data as an aggregator system from multiple field locations and share data with utility SCADA systems on standard interfaces. One can also use the collected data for building or integrating custom applications on top of the platform, again using standard interfaces provided. Thus, one can see how kalikiio centralized platform software as a service reduces capital investment without compromising on both data security as well as regulatory compliance. A brief on Kalkitech. Kalkitech has long been an advocate of open standards and standards-based communication to facilitate interoperability in the true sense. Our solutions enable customers implement mission-critical applications across the smart grid solution spectrum, ranging from substation automation to wide area monitoring, distribution automation to advanced metering infrastructure. To introduce myself, I'm Gautam, and I take care of Europe and Latin America business for Kalkitech ASE offerings. ASE being the US-based company acquired by Kalkitech in 2014-15. A few points to keep in mind before we start off. Since we have a large number of participants, this is a listen-only webinar. However, to facilitate clearing of your doubts or queries that may arise during the course of the webinar, feel free to send us your questions by typing in the window provided during the talk itself. We would try to address most of your queries here or come back to you individually in case we run out of time. The presented talk would be for 40 to 45 minutes, followed by the questions selected at random. I would now like to introduce you to our panelist for today's webinar, my colleague, Mr. Nirmal, AVP Product Management, IoT Division. Nirmal has over 15 years of diverse experience in substation automation, communication protocols, and the other power utility automation, which include smart grid solutions for distribution networks, DER integration, smart metering, and IoT solutions. Nirmal is now responsible for product management and marketing for energy IoT products and offerings of ours. Without any further ado, I would now pass controls to Nirmal, who will take it forward from here. Over to you, Nirmal.
Thank you, Gautam, for the introduction. Hi, all. So let's jump right into the session. Okay. So welcome to the webinar on remote management data access for the solar PV systems. Today, we will discuss upon the challenges and limitations in solar PV monitoring solutions and how kalikiio solar data package as a service helps in addressing these challenges and limitations. We'll also have a brief look at the typical solution architecture and the various components used in arriving the solution. Later, we'll also have a look at the top 5 security measures to be considered while designing a monitoring solution for a solar PV system, including the solar farms as well as the rooftop solar, mainly the commercial rooftop solar systems. We'll also have a high level look at the use cases. We will talk not only about monitoring, we'll have a quick look at the what are the advanced analytics functionalities which can be added, or we can also have a look at the remote device access package could facilitate the solar PV systems. We'll have a look at the deployment and the subscription model of kalikiio solar package. So start off from the challenges and the limitations in the solar PV monitoring system. So we all know that there is a monitoring system already available for the solar PV systems for both for the big solar farms as well as for the commercial solar rooftop applications. But there are a few challenges or limitations pertaining to those kind of systems. We'll look at those challenges right now. So there could be a limited role-based access and control across the fleet. Means you don't the system exposes data not specific to specific user roles or the privileges he has on the organization. For example, the asset owner, the management or CFO needs to view at a particular different set of data compared with a site administrator or a maintenance engineer. So there should be a role-based access control for each data or each assets across the fleet. And there could be also site engineers allotted for different sites, which he or she should have access to only the sites which he has the privilege to. So those kind of RBAC, that role-based access control, is lacking in the most of the monitoring system. Then monitoring system collects a huge amount of data from inverters, string combiners, or the weather stations, and all. So all these data, which is right now collected from these devices or these sensors, provides a much more information than what is being seen as a raw data. If you dig deep into the data and correlate the data relationship, you can identify and the issues which is hidden inside the systems, and you can also use that data with analytics functions for doing the corrective and the preventive maintenance of the systems. So what I'm talking is only about the data which is right now collected from the field, and there could be deployment options for more number of IoT sensors like wind or breeze speed, how the wind is going to affect the cooling effect of the panel, and how that will impact on the efficiency of this panel. So there are a lot of more sensors which can be deployed and which can be used for identifying the output or the performance of the systems. So those kind of IoT sensor integration is not typically possible with the legacy SCADA-based systems. And right now, most of the SCADA systems are typical local SCADA, but there are centralized SCADA system as well, which looks onto the multiple assets, multiple sites. But the main differentiation or main challenges on those systems is the inadequate security measures in terms of data security, in terms of the data access and authentication. So that kind of advanced security measures are lacking in case of local SCADA or the central SCADA-based design. And a typical system would be made for communicating with a set of devices, like a set of inverters or a set of controllers or PLCs in the field. You cannot make it as a generic head end or the generic data collection system for all types of inverters or all types of devices deployed at the field. So that is again one of the other challenges which we are seeing in the legacy monitoring system. And the SCADA also does not provides a secured remote access to these devices. Like, for example, with the arrival of DER and the smart inverters, you could pump in the control the volt var and make the distribution grid stabilize and improve the power quality of the grid. So those kind of var pumping can be done using the inverters by doing some remote settings. So those kind of settings may not be possible from a legacy SCADA systems, which is possible from a centralized platforms like kalikiio. So with this, more control on the assets and the production and the devices gives you production and improve the portfolio generation of your systems. So now let's look at how kalikiio Solar Data Pack, which is a cloud-based software as a service solution, which you can subscribe from our website and connect your devices directly to it or a secured TLS 1.2 tunnel, and this data can be used for your application, including monitoring, analytics, or any control functions as well. So we'll look at the typical solution architecture. So in this diagram, we have depicted two applications. One is the rooftop solar, and the other is a solar farm. And our data collection from these field devices can be done using an edge gateways. It could be a standard third-party edge gateways or a edge gateway which we provide called Sync Connect. This is software which can be installed on any standard hardware computers, including the embedded computers and industrial computers. So Sync Connect can collect data from the revenue meters or weather stations or other IoT sensors and inverter rooms in the solar farms over various communication media like the serial or Ethernet or wireless mechanisms. Mainly for wireless, it will be low power, low frequency wireless communications can be used. From the edge gateways, all the data will be consolidated and will be pushed to the central server, that is kalikiio, a cloud-based system, where this data can be used for monitoring, analytics, or any other advanced functionalities as per the user requirement. Similarly, in case of rooftop solar, there could be more devices or more types of devices connected. For example, there could be a net metering, or it could be energy storage devices. All these additional devices can also be connected to their gateways, and the data can be sent out to the cloud-based systems. And here in the cloud-based system, you can have a role-based access control where you can even control what are the devices to be exposed and what are the sites to be exposed, what are the data to be exposed to different set of identities and roles of the entire ecosystem. So to talk about the main solution components, we have got Sync Connect, that is an edge software gateway, which this is a software which can be installed on a standard edge devices, mainly the Linux devices. And main functionality of the device, this software, is to collect data from various assets or IoT sensors or the controllers in the field, consolidate all the data, and send it out to cloud system. it can send data to kalikiio, that is one of the cloud platform. It can also send data to standard industrial cloud such as Amazon or Azure or Google, etc. So it supports a various set of protocols, especially the Modbus, Sunspec Modbus. This is a companion standard for the inverters, mainly used in the US. IEEE 2030.5, again that's a standard released by IEEE, which most all these smart inverters has to comply to. And you could also find inverters talking on DNP3 or IEC 61890-7. This is a safety data model for a energy storage and energy converter devices. So it has got around 60 plus protocol support to collect data from various devices in the field, and this data stream can be processed online. If you want to do some analytics functionalities at the edge, it can be done using the real-time streaming and processing engine, or you just need to send the raw data to the cloud or to the SCADA systems. You can send data to the raw data to SCADA or to IoT platforms on standard interfaces, which the SCADA or the IoT platform supports. For example, MQTT or maybe to Modbus or other protocols, other telemetry protocols. So talking about the kalikiio.io, this is a central software which is cloud-based software, which has got various functionalities on the for the monitoring. For example, the dashboards and reports are used for the monitoring purpose. We will have a quick look at the set of dashboards which is configured in the kalikiio.io at the end of this session. And also the kalikiio.io can be used to facilitate the remote access of the field devices, again securely on device specific protocols. And it can also has the notification engine. It can be configured to send out the email or the SMS notification to the configured set of users or operators in case of emergency needs to be attended by these operators. And again, a role-based access control is additional functionalities provided in the kalikiio.io, which enhances the usability for different set of roles and the identity in our organization. And kalikiio.io can also be used for the managing the various devices in the field as well. Now let's look at the top 5 security considerations and or security measures which you need to consider while designing a monitoring system for a solar PV farm or rooftop solar system. Main criteria will be the control and management of accessibility, that is the role-based access control of devices and the data which it is exposing from the platform. And it could be based upon the public key infrastructure. You can have each devices or each users can be connected with the IoT platform using a PKI infrastructure, using certificate or using the token generated from the platform. Again, for users, there should be a optional two-factor authentication mechanisms similar to what you have seen in most of the standard mail servers. In addition to password, you can also enter a token. It could be a time-based token, or it could be any other unique identification can be used to generate the tokens. And that should also be used in addition to the password to log in to the systems to improve the security of the entire system. And even if the user or device is trying to connect for more than a configured number of times and it's getting failed, that device will be permanently blocked, or that particular user will be permanently blocked to access the devices unless it is been granted by the administrator. So that is the accessibility control mechanisms should be considered while designing a system. And another factor is the confidentiality of the packet exchange. That is the how confidential you are going to store the data, how this data is going to be protected while you transfer from field devices to the SCADA system or the IoT platform, and how that is going to be presented to the user or to the any external application securely. So the system which you are kind of designing should be compliant to, you should have the TLS 1.2 encrypted encryption mechanism while where you're transferring data from one entity in the network to another entity in the network. That is highest level of security which is there in the market, which will give you an enhanced security while transferring the data, and also while storing the confidential informations like the passwords or some keys of each devices or users. All those information should also be encrypted and stored in the database or wherever you are going to store the information. And another factor is the integrity of operation. So you should also have the integrity check that if you are going to access a devices, you should ensure that the device which you are going to access is actually that device which you want to access. It is not the a dummy or a malware device which is going to connect to the network, and somebody is going to tap in and get you all the information which is required from you. So that integrity check is required for both users as well as for the devices which you are going to connect into the network. Maybe you can use an X509 certificate-based mechanism for this kind of integrity check. And safety of access and people is also a critical factor for the or security factors for designing the network. And another criteria would be the availability of the system. You should also consider a disaster recovery center. If it is a central system which is monitoring multiple sites and multiple portfolios, there should be a disaster recovery center which will have a continuous data backup mechanism from the main site to the backup site. And even in the single site, there should be also be automatic load sharing mechanisms in such a way that if one particular site is going to hit a load more than a threshold value, and automatically that load should be shared with other servers in that particular site. So that is another security measures which you need to be considered. And the traceability of operations or actions which is used invoked by the user. For example, if user is going to set a particular settings in the inverters, all the operations which he is going to do on these devices should be logged and should be available for future audit trail purpose, mainly for the tracking the or having a ownership for each and every actions taken by each individual users. And these logs should be available on a standard repositories like, for example, syslog server or a third-party syslog services available. So now we can look at the use cases of using kalikiio for the solar PV systems. One of the primary use cases is the monitoring. That is, this is a typical solar farm where you have got multiple strings attached, and each strings has been connected to a string combiner boxes and then to inverters. Like that, there's multiple inverters available in the system, and all the data from these inverters is connected to the edge gateways having sync connect or maybe standard softwares. And it should also have a capability to share the data with a local SCADA. If local SCADA is available, edge gateway should share data with the SCADA, and also it should share data with the central platforms such as the kalikiio system. And from kalikiio, you can use this data for the portfolio monitoring, where you can monitor the multiple sites or multiple locations of your assets in a single screen. And you can also use it for the revenue monitoring, how much energy is being generated and how much the cash inflow and what is the projected cash inflow with the available data or forecasting data available in the system. And you can also use for performance monitoring, and you can like performance on inverters or performance on string combiner blocks, or even performance of an individual panel can or should be monitored from a central system. And it should also provide an adequate warning to the operator or the site in charge if there is any maloperations or if there is any performance degradation of any of the assets in the network. And this kind of a system should also be compatible with communicating with the multiple types, multi-vendor devices like inverters from multiple manufacturers as well. And it should also have the end-to-end topology heat map, including the small-scale GIS information should be available in kind of a centralized monitoring platforms. And in case of alarms, this is a typical use case for a site in charge or site operator, where you want to have maintenance in charge of the maintenance wants to get alarmed if there's any threshold violation happened in particular site. You should be notified immediately using SMS or some other notification mechanism like a mobile app, etc. There should be also be functionalities of these IoT platforms, and there should also be report generation, which could be a monthly report or a weekly report, or maybe any yearly report. And reports can also be based upon the users or the roles who is going to access the data. For example, the reports we generate for the CFO could be a revenue report, but for the site engineer who wants to who was in charge of the maintenance of the site, who wants to report on the number of critical alarms or number of events which needs to be monitored, or number of abnormalities which is been recorded in the sites. Those kind of reports should be available for different set of users. And another functionality is the of data access, the advanced analytics. For example, there should be provision in these platforms. For example, in kalikiio has got the provision for user to add a custom application on top of the platform for advanced analytic functionalities. You want to do some analytics on the data which is collected from the various assets. You can do that by accessing the data from kalikiio using the REST APIs. And using the REST APIs, you collect the data and you use your analytics engine or algorithm to go through the data and do some analytics. For example, the generation forecast or revenue forecast, failure analysis, problem classification, root cause analysis, or precise degradation monitoring. Example can be done as an additional application on top of kalikiio. In this example, this is an example where you have classified the problems in terms of assets. Like most of the problems reported or events reported for a particular location site is on the inverters. That is 1227 events is been recorded on the inverters. But for the grid side or combiner or DC disconnect and other things, the number of events is much far lesser compared to the inverters. So this kind of analytics functionalities or the advanced data analytics functions can be used by the operators or the system integrators or the maintenance team to go through this data and do the corrective actions required. So these are purely customized. You can use the Rust API and bring in your analytics engine, bring in your analytics module, and run those analytics engine using the standard interfaces provided by the kalikiio Rust interfaces, so that you don't need to your analytics application, you don't need to depend on the different set of protocols or different set of communication libraries, needs to be supported to talk with the various types of field devices out there. So another use case of kalikiio is the remote management, where you need to do some reprogramming, or you need to do some configurations or software updation of these assets in the field. You can do that using the vendor specific tool directly from your laptop through the kalikiio. So for this kind of an architecture, you need to have a small software called kalikiio remote connector. This is a application it can be run on a Windows machine, and you using this remote connector application in your PC, you can establish connection with any field devices through kalikiio through an internet. So you can connect your PC to internet and connect with kalikiio and access any of the devices. So you will get access to only the devices which you have got privilege to. So in kalikiio, you will be provided with privilege to access the inverter 1 or maybe string combiner bus, and not to inverter 2, for example. In that case, you can access only this inverter and string combiner bus. Other devices cannot be accessed remotely for you. So similarly, the field side, you can have multiple topologies, like for example, the solar farms. You can have edge devices directly connected to internet, and edge device can connect directly to the various assets using the LAN network, that's Ethernet, using the serial communication, could be RS-232 or 485 link, or even could be a USB link. If there's any kind of a USB devices available, you can connect directly with the edge devices through USB, and can be exposed. Those ports can be exposed outside for any maintenance engineer or device OEM expertise to connect with these devices and do the maintenance work. Similarly, in case of commercial rooftop, maybe edge devices will not have direct access to the internet. It will be connected through a commercial internet service provider, either through a centralized firewall, and internet is provided distributed through a Wi-Fi network, or it can be a LAN network from a corporate router to the edge gateway. And from the edge gateway, you can connect with any of the assets in the field through the local LAN. So for those kind of topologies also, you can use a sync proxy or sync connect at the edge devices, and provide an access to these devices to a remote maintenance user. So this particular remote management is mainly used for 3 applications, so 3 use cases, like remote diagnostics of these devices. It could be used for remote programming or re-engineering of these devices. It could be also used for the software updation or upgradation of these devices as well. So for this kind of solution, there is already topology available using VPN. You can have VPN based solution, but there are a lot of disadvantages on the VPN based solutions compared to a cloud based solution which is provided by kalikiio. We'll look at what are those disadvantages of using a VPN based solution and the kalikiio remote access solution. So typically in the VPN network, you will have a VPN client available in the field along with the field devices. It could be inside the field devices or outside the field devices on a edge or on any other hardware. And VPN client will establish a connection with the VPN server or over an SSL VPN or IPsec VPN. But in those kind of a scenario, user will have access to all the devices connected to that VPN network. There is no device-specific access control in case of the VPN. That is, if user one needs to access to device one, for example, the inverter in site A has to be accessed by user one. So that kind of control cannot be provided for a VPN-based solution. And also the user within the user, you can also have user level access, role-based access. So, for example, the operator need not have the permissions to do software updation or reprogramming of a device. If user has logged in as an operator, there should be access privilege control mechanism where he should do only the monitoring of the data, not reprogramming or updation cannot be done from for the particular operator on that level. In case of VPN, we cannot have that kind of a control. If one user has got access to a network, he usually have all the access to all the nodes in that network. So that is another disadvantages. Again, mostly VPN-based solution requires service provider hardware. For example, the edge devices, which will be run the proxy service or the VPN client, will be the service provider itself hardware. You cannot use a standard computer or embedded box industrial computer to establish a VPN network, mostly. And also another disadvantage is it is not scalable. It depends upon the IP range which we allocate to that network. But in case of kalikiio SaaS-based solution, it is scalable and there's no dependency with the IP network. And in the VPN, there's a limited control on lossy network. For example, if you are using a low power radio on the last mile, VPN does not adapt the payload, data payload, as per the communication topology or communication technology which you are adopted at the various entities in your network. So that kind of adaptation is limited in case of a VPN network, but kalikiio SaaS solution can work on the low power lossy network as well by adapting the MTU size, the protocol payload size, depending upon the topology or the technology which is available, which is used to communicate with any devices. In VPN, you need to access the device using IP address. That means you need to remember which are the IP address of each devices, and you need to connect to that IP address to connect to that devices. But in case of kalikiio.io, you will browse the devices from the web page, and if you have access to that devices, then you can directly click on that device and connect directly from the browser. And also from the local PC, where you are connecting from your office or maybe from your home, there could be a limited possibility to do the diagnostics or to know what is happening in the network. So there's no UI, there will not be UI to monitor the utilization, bandwidth utilization, or the performance of the network. So that can be easily monitored from a SaaS-based solution where you have a small UI to see the communication throughput and latency in the network. And that, of course, there's as part of security measures, there is an audit trail built in as part of the platform, where you have got access to all the operations which any user has done or through the platform. But in case of VPN, once the network is established, there is no audit trail or there's no control on what are the events or that are the communication happened through that network previously. So these are the some advantages of using the kalikiio SaaS solution for a remote device access for any remote management or configuration of the field devices from a central server or from a remote location. So, so let's talk about the deployment options. So kalikiio can be deployed on cloud. It could be default option is public cloud, where you can go to www.kalikiio.io.com, where you can uh, see create an account and access the Solar data pack and straight away connect your devices to that pack. Or if you want to have your own dedicated private cloud, that is also an option where you for your specific customer can also be deployed. That is the two cloud deployment, private public cloud deployment and private cloud deployment. And there are two on-premise deployment option. That is, kalikiio can be deployed on your hardware, where you can give us the bare metal hardware. kalikiio can be installed on. Or second option on on-premise is we ship the kalikiio with a server pre-installed and pre-configured for the particular site configuration. So that is the fourth option, preloaded appliances with the kalikiio. So these are the four deployment options for kalikiio. And for the cloud-based option, this is the subscription model where there's a base price depending upon the devices which you want to connect to, that is inverters or any other IoT sensors which you want to connect to the platform. There is a base price for that depending upon the device number of devices which you got connect to, and you can also add the storage as per your data retention requirement, and you can also add the number of users as per the organization hierarchy and organization structure you have. And also you can also limit the network usage. Mainly this network usage limit is mainly applicable to the outbound data exchange from the kalikiio to any third-party applications which you build. For example, if you are building an analytics application and you want to take data from kalikiio more frequently, then you might need to subscribe for more network usage. So that is the whole purpose of the network usage limit. You can control that limit from the subscription model you select. So now let's look at just a quick video on dashboards, where you can see that this is a dashboard. You can see the pan monitoring, where you can also have the utilization of the plant, where our total capacity of the plant is there, and then what the generated capacity, and then instantaneous power outage from this plant, and also the status of the grid connected, like if the particular site is connected to the grid or not. And you can also have the power generation for each day. What's the power generated for a particular day, and you can change the dates and see what is the power generated for the particular dates. Similarly, there are different types of graphs like the area graphs or line chart or the bar chart available. So depending upon the requirement, you can customize these dashboards. These are all different widgets. You can resize this depending upon your requirement, and you can customize this for a particular different set of users. And there's a comparison dashboards, the inverter comparison dashboard, which you can see the comparison of different inverters data. This inverter 1 and 2 output power generation is being monitored here. Similarly, this is the clustered comparison of two inverters. It could be comparison of two inverters, or it could be the comparison of inverter with a reference inverter. And this is a chart for the stacked chart for the two inverters where total power is being captured here on monthly basis or yearly basis. So you can specify what are the you can monitor the what are the generations. Also filter out what are the inverters to be shown. And this is a heat map which shows the utilization of inverters. This is a comparison of two inverters, inverter 1 and 2, where you can see that the power generated from two inverters for this particular date is different depending upon the generation capacity. So that's all on the sample screens which we provided. To conclude, I'll just explain what are the benefits for different stakeholders. So asset owners who is owning a solar farm or uh, rooftop solar commercial space can make use of this platform or solutions to increase the ROI which they have spent on the um, for setting up the solar plants. It can be done by continuous monitoring of the generation yield, and it can also use to increase the lifetime or life of the system by having a proactive maintenance from the data collected from these devices. And I can also use this data for further planning of your portfolio, like whether you want to invest tomorrow to um, for capacity addition of the same plant, or you can have additional sites can be added. So those kind of decisions can be taken from the historical data which is been available from the central system. Similarly, for the operators can make use of these platforms to reduce the cost of operations by reducing the unplanned incidents, and the outage can be reduced maximum using the continuous monitoring of the plants. And we can also use add-on analytics module for the corrective and predictive maintenance and improve the operational efficiency of the systems. So these are the benefits for the plant operators. For the OEMs, for example, the inverter manufacturers, etc., can use the platform to improve the life of the product. For example, the OEMs mostly have an AMC contract or maintenance contract with the asset owner who has supplied the product to the system. Uh, for having a remote diagnostics or remote maintenance of systems, you can use the kalikiio for the continuous monitoring and improvement of the system. And another stakeholder is the solar aggregator or the grid operators, or could be a utility who is connecting to the on-grid solar PV systems, where you can integrate the data from a central monitoring system to the DERMS applications using the standard interfaces, which is provided by the DERMS. And it also ensures the regulatory compliances by seamlessly integrating this data with the grid operators uh, or the transmission grid operators, etc. So with this, we can conclude our today's session.
Thank you, Nirmal, for the detailed talk. Let's move on to the questions. Nirmal, if that's fine with you, we have got a few questions from the participants.
Yeah, sure.
So one of the questions was how the Kalki.io platform can share data with utility external systems such as DERMS.
Okay. So I'll go to the architecture. So this solution does not give a detailed picture of the data exchange with the utility system. So Kalki.io can exchange data with the utility system like EMS system or the DERMS through a standard telemetry interfaces. So it supports the utility standard interfaces like DNP3, IEC 60870, 104 or 101. It also have support for the ICCP, that is Inter Control Center Protocol. So usually we have integrated the with the EMS systems using these three set of protocols. You can share all the relevant information with those systems using these three protocols. Or it can also be done using standard protocols, legacy protocols like Modbus, etc. If utility wants to uh, collect data through Modbus, that is also possible. But normally, in case of utility systems, what we have seen is ICCP, Inter-Control Center Protocol, where there's a bilateral agreement between the external nodes, external entities, and the utilities SCADA systems, which all data can be exposed, which all data can be exchanged between those systems. So those kind of control is provided using the protocol called ICCP. That can be used, or DNP3, Modbus, 101, etc. can also be used.
Okay. The second question from a gentleman was, can we customize the analytics module, including the algorithms?
Yeah, so to have clarity on that, so we don't provide the analytics module. So we are just a data acquisition platform. We collect data from various types of devices. We have the security. We manage the security. We manage the connectivity, and we manage the data collection and the communication aspects. And all the data collected from these devices are exposed using the REST interfaces, where you can take the data through REST APIs using JSON or the XML schema. And there are some partner application which we already have, or you can also build your own application which can connect with kalikiio.io using the APIs and build your own analytics modules. So to answer that, it's all on your control. You can customize, or you can do anything on your analytics application, as far as we are just giving the data through the REST interfaces.
Okay. So there are a couple of questions which are related. So I'll just say them one after the other. Can I run Sync Connect on my own hardware? And what are the system requirements for Sync Connect?
Okay. Sync Connect is an edge gateway software which standard option is Linux compatible and in x86 or SS64 compatible software, which is freely available from our website. You can download it and run that for an evaluation. For the Intel platforms, Intel x86 or Intel SS64 platforms. But there's no limitation, or Synchronous is not limited only to those architecture. We have custom comparison option to build on third-party hardwares as well. In fact, this is already deployed by few of our customers on Raspberry Pi, small modules, which comes with ARM Cortex architecture, as well as a few other vendors like PLC manufacturers or the modem manufacturers are also installed Sync Connect on their hardware, which are having different architecture other than Intel, like ARM Cortex is one thing, and PowerPC architecture. So these two architectures is also already been supplied and deployed by various partners. So
Okay.
it is possible to, yeah, it is possible to run it on your hardware. Ideally, so we need to have the compatibility. So to answer the second question, the how much the
System requirement.
System requirement. So for that, ideally it can run on hardware which has starting from 32 MB RAM. But we say around 128 MB RAM is a good option, perfect option to run a sync connect, and 150 to 200 MB flash if you have, that will be adequate footprint to install the sync connect protocols libraries as well as the additional libraries which it required. So 200 MB flash and 128 MB RAM would be fine.
Okay. Nirmal, there's one more question. I think we covered this during the session, but I'll repeat it. How is kalikiio.io different than the local SCADA system?
Kalikiio.io, as we just go to the Kalikiio.io is different mainly in terms of the deployment nature and securities considerations which it already have. Local SCADA system has got limited functionality or limited scalability. You cannot scale it beyond a specific limit. But kalikiio.io is fully scalable and can have any number of devices or data connected to it. And this is secured with the latest security compliances in terms of confidentiality of the data, in terms of integrity of the data and devices, in terms of role-based access control, which which has been provided, in terms of the connectivity with the latest types of devices like IoT sensors or other new sensors available in the field. And it also has the capacity to add on your own analytics module using the REST API. So all these are something which normal SCADA does not provide easily. If you choose that SCADA which has a role-based access, it cannot have the plugin option to analytics, or it may not have the plugin option to connect to your IoT controllers, or it may not be interoperable with the multiple types of inverters, or it could be security may not be adequate enough on that. So there are various factors which determines that kalikiio is different from a local SCADA. So even you can install kalikiio or instead of your local SCADA. Just need to have a server, a local server, where on-premise kalikiio can also be used. In case cloud option is not an option for you, you can have on-premise kalikiio.io, which can be installed on a small hardware, and that can be used as a SCADA system with a web interface as well.
Okay, due to shortage of time, we cannot take any further questions. We'll come back to the gentleman who sent few questions and come back to them. Okay, thank you to all the attendees for taking time out to attend this webinar. If you have any additional questions or queries, feel free to drop us an email at marketing@kalkitech.com, and we'll be glad to assist you. We will also be sending a recording of this webinar shortly to all the participants who attended. Have a great day and take care, everyone. Bye-bye.
Thank you.